Now that I have an attribute for elevation in feet, I can select features using that attribute. So let's go ahead and type in elevation feet, double click to complete, greater than 900. Select features. Those are the sites with an elevation above 900 feet. Likewise, switch that around to less than. Select features. Those are the ones less than 900 feet. Let's clear these selected features and go into the symbology of this layer so we can display by their temperature. So we'll go from single symbol to graduated. And we're going to change the symbol, not there. We're going to change the value to average daily maximum, July and August. And we're going to classify here. So the white is down in the cooler range of temperature, and the red is up in the higher range of temperature. Okay. And now we can do a very quick visual assessment of this data set. So keep an eye on the pattern here. We have warmer temperatures down here, a few cooler temperatures up here. Select the ones that are at lower elevation, below 900 feet. There they are. Clear that selection. Select features again. Clear the selection. So we can see that many of the lower elevation sites happen to be warm, but also some of these higher elevation sites also happen to be warm. Elevation may explain some of the variation in temperature, but not all of it. And in my formal statistical analyses, I find it explains very little. So we're left looking for other explanatory variables for why the streams are warm. Now, we're not far enough along in the class to generate this variable, but I'll give you a hint. It's the stream gradient, how steep the stream is, how fast the water is flowing, that best explains temperature. It doesn't explain all of it, but it gives an R-squared value of somewhere over 0.3, which is quite good. That means that stream gradient alone explains 30% of the variation observed in the dataset, and it can be useful in predicting whether a stream we have not measured is likely to be warm or cool, especially in combination with other factors like is the stream flowing out of a pond or a wetland, which would slow the water down and allow it to be warmed up in the sun. Another useful thing in these queries is the ability to type in an equal sign here. So where elevation in feet is less than or equal to 900. Select features. That's not likely to identify any because these have 3 decimal places, and nothing is likely to equal exactly 900. But if you have an integer data set, you're much more likely to have that happen. Let's write a new query that's going to illustrate that. So we have this point here, 758 feet in elevation, actually 758.113. So if I type in elevation in feet less than 758, select features, that's not selected because it's greater than 758. If I switch this to look at elev feet, instead of elevation feet, this integer data set I have here, select features, it's still not selected because this is not less than 758. It is 758. So I have to write less than or equal to 758, and now it is selected. You can likewise write greater than or equal to 758. What do you think is going to happen? Will this still be selected? Yes, it is greater than or equal to 758. But only by this measure, only by this integer data format. It is greater than 758, it's 758.113. So it matters a lot how you ask this question, greater than or equal to, or just greater than, and are we querying a data set that is an integer data format or a data format that has decimals?